what happens when a 70-kilogram man gets hit with a 15-kilogram bag full of books at about 3 meters per second. All right, you got that, Theo? And then we're going to fully analyze this in the video after. That was good. Here we have a 70-kilogram man standing on a frictionless surface catching a 15-kilogram book bag at 3 meters per second. So the man has an initial velocity of 0, but the book bag has a velocity of 3 meters per second. How fast does the man and the book bag end up going? So the concept we're going to use to solve this problem is called the conservation of linear momentum. So we're going to look initially at the man and the book bag. So initially, the man has a mass of 70 kilograms and a velocity of 0 meters per second. The book bag has a mass of 15 kilograms and it has a velocity, let's call that 3 meters per second. And because that's a vector, we've got to give it a direction. We'll call that forward. So the book bag has a mass of 15 kilograms and is going 3 meters per second forward. And the man has a mass of 70 kilograms and an initial velocity of 0. So the momentum of the man initially is 0. And the momentum of the book bag is the product of its mass and its velocity. So the momentum of the book bag is 3 meters per second forward multiplied by 15 kilograms, which is 45 kilogram meters per second forward. So momentum's a vector, and the initial momentum of the book bag is 45 kilogram meters per second forward. The initial momentum of the man is 0. After the collision, so after the bag hits the man, the system of the man with the book bag together is going to have a final momentum equal to the initial momentum. So finally, the final momentum of the entire system is going to be the same as the initial momentum of the entire system. The initial momentum of the entire system was 0 plus 45 kilogram meters per second forward. So the final momentum of the system is also 45 kilogram meters per second forward. The mass, the final mass, is the same as it was before, but the two bodies have become one, essentially. So where we had a 70 kilogram man and a 15 kilogram book bag, we now have a 70 plus 15 kilogram system. So we have a mass of 85 kilograms. And what we're interested in is finding the final velocity. Now remember, momentum is mass times velocity. So that means that our 45 kilogram meters per second forward is equal to our 85 kilograms times our unknown final velocity. Now all we've got to do is divide both sides by 85, and the final velocity is 45 divided by 85 meters per second, and that's going to be forward. So our velocity is 45 over 85, and the direction is forward. So that's 0.53 meters per second forward. So let me recap. We started out with our system initially. We have a man that's not moving, and we have a book bag that's moving at 3 meters per second forward. Afterwards, we have a man and book bag system that's moving forward at some unknown velocity. In order to find that velocity, we found the total momentum in the system. So initially, in our system, we had a man with a mass of 70 kilograms, but no velocity, and a book bag. And that book bag had a mass of 15 kilograms and a forward velocity of 3 meters per second. The momentum of the book bag was the product of mass times velocity. So 15 times 3, it was 45 kilogram meters per second forward. After the collision, we ended up with this single system where we have a man with a book bag. And that single system had the same momentum as the total momentum before the collision. That's the principle of conservation of momentum. The momentum after a collision is going to be the same as the total momentum before a collision. So after the collision, we had a forward momentum of 45 kilogram meters per second forward. Our system had a total mass of 85 kilograms. That 85 kilograms was the 70 kilogram mass of the man plus the 15 kilogram mass of the bag. That's what gave us 85. And the product of that 85 kilogram mass and the unknown velocity was equal to the momentum. The momentum was, as we calculated from the initial conditions, 45 kilogram meters per second forward. So after doing a little bit of arithmetic, dividing by 85, well, I guess a little bit of algebra, we find that the velocity is 0.53 meters per second forward.